Now we are going to start with the chemical properties of the carboxylic acid. So actually you know that carboxylic acid, as I told you in previous lecture also, that it is actually formed by the combination of carbonyl group with the hydroxide group. So due to you must be thinking that it must be showing the properties of these two compounds. So it's right that it tends to show the properties related to the carbonyl and the hydroxyl group. So what we see that we can actually cleave many type of bonds in it, and accordingly we can get many compounds. So we have few chemical properties for you. That is the the reaction in which there will be a cleavage between OH bond. As you know that bonding is such that, so in the first reaction what we will see that there will be cleavage in this. That means it results in the release of hydrogen ion. And second reaction is that in which we will observe the cleavage of CO and OH, because particularly it is COH. So here the bond will cleave in this way, that will result in the formation of separation of actually OH and the CO group. Third is the reaction involving the fully carboxylic acid, means that fully carboxylic acid group is going to change into certain kind of thing, and there will be a reaction due to alkyl group or the benzene ring, right. So let's start with the first type, that is the cleavage of OH bond. As I told you that in this case the bond is going to cleave in this way and it will liberate hydrogen ion. So that means it suggests that it has an acidic character, because we know that whenever the hydrogen ion is released, then obviously the substance is regarded as acid. So before starting with the first property or starting with the reactions involved in that, I just want you to know the acidic strength of this carboxylic acid group. So what you will see that when we talk of like COH, it remain as such when we in a liquid state, but in an aqueous state actually when we dissolve in water, it gets break up, and what does it form? It forms the carboxylate ion, and along with that it forms the hydronium ion. As this release of hydronium ion just suggests that it is acidic in character, because you know that according to Arrhenius, any substance when dissolved in water produces hydronium ion is regarded as an acid. So that means this is an acid, right, acidic in nature. So if we write an equilibrium constant, or you can say ionization dissociation constant for an acid, so we can write in this way that the product, that is this hydronium ion and the acetate ion, divided by the reactant, right. So as we see that this K is actually directly proportional to this thing, that means the carboxylate ion and the hydronium ion. So that means if the value of Ka increase, so obviously the strength of an acid, means tendency to give hydronium ion also increase. So that means if you have a greater value for ionization constant for an acid, the greater value of ionization constant for an acid indicate that it is a strong acid. That means it has a relevant strength. But if there is a small value of Ka, it determines that the acid which we have is actually a weak acid. So likewise, depending upon the value of the Ka, you can actually determine the strength of an acid. We can also talk about the strength of an acid by taking into consideration this expression. We know that pKa is equal to minus log H positive. So if so that means lesser is the value of pKa, that means stronger is the acid. Stronger is the acid, and vice versa, more is the value for pKa, that means weak is the acid. Right. So you can actually talk about the strength by taking into consideration the ionization constant for acid and also this pKa, that means pH for this Ka. Now you know that if the value of pKa falls between particularly you can say 1 to like if you talk about strong acids first. So for strong acids it is actually less than 1, and this is for strong acid, and particularly 1 to 5 for moderately acidic, and 5 to 15 for weak, and more than 15 for the weakest one. So this is how the value of pKa actually suggests that what is the nature of the acid, right. So now you must be thinking that though it has been proved that it is releasing a hydronium ion, that means it has an acidic strength, but you know that what is the reason that it behaves as an acid? The reason lies in the resonance. The reason is resonance. So here you know what happened, there is delocalization of electron. You know that the resonance is something delocalization of electron, which you can see in this case. So if I talk about the carboxylic acid, so particularly it has a structure like this. So this can happen that this bond these electron pair gets shifted here and this gets shifted here. So as a result, what we are going to get is this bond will become single, the lone pair will move here, it will acquire partial negative charge, and here the bond, because the electron pair is shifting here, so it will acquire a double bond, and there will be H and it will acquire a positive ion. So that means in this case oxygen is just you can say that it has a positive charge and it has a negative charge. So that means somewhat this bond actually gets weaker. This bond actually gets weaker, and whenever there is a withdrawal, because as it is a positive charge, so that means it must be attracting the shared pair more towards itself. So as it is attracting shared pair more toward itself in order to stabilize the positive charge, so that means this bond actually or you can say this hydrogen actually becomes deprived of the electron pair, and the release of hydrogen ion becomes possible. So if somebody is going to ask you to comment on the acidic nature of the carboxylic acid, you are going to show in this case that as it possesses a structure like this, but you know what happened, this double bond electron from this one bond out of these two double gets shifted here, as a result it gets partial negative charge, and the electron from pair from here to shift to this side, and as a result it acquired a positive charge. Now as you can see the delocalization of electron, and as there is a positive charge on oxygen, so that means it is going to attract the shared pair of OH to more towards itself in order to stabilize, neutralize its charge. So as a result the hydrogen will left deprived of the electrons, and you can say that this bond will be easy to break and there will be a release of hydrogen ion. So this is what is the reason that carboxylic acid actually possesses an acidic character. Now you know that what are the factors that actually cause this delocalization of electron more, or what are the factors which can increase the acidic strength or which can just decrease the acidic strength. So you have seen here that here it has a positive charge and it is acquiring this thing electron pair of OH bond more towards itself. So that means any electron withdrawing group, if attached to this kind of thing, so that is going to withdraw the electrons, and somehow it will increase the polarity of the bond, and due to which the release of this hydrogen ion becomes possible. So that means any substance that is electron withdrawing group, any group which show minus I effect, so that means it has an electron withdrawing nature. So whenever this kind of group is attached, it is withdrawing the electron more toward itself, and it is just making the release of hydrogen ion more easier. So this is what this is how that any substituent can increase the stability of carboxylate ion. Any means only the electron withdrawing group, otherwise withdrawing group. Otherwise, if we have electron releasing group, they will somehow increase the positive charge, and the carboxylate ion will somehow be less than the stable means the particular stability. So that means any substance, any substituent which increase the stability of the carboxylate ion, just you can say increase the acidic strength. So what are those substances? What are those substituents actually? They are the electron withdrawing groups, or the groups which show minus I effect. Second is that more is the electronegativity, more stabilization of carboxylate ion, or more is the acidic strength. So it is again clear, like if we talk about halogens, because halogen is a group which is an most electronegative group. So we know that fluorine is more electronegative than chlorine, followed by bromine, then followed by iodine. So that means if fluorine is attached, obviously it is an electron withdrawing group, but as it is smaller in size, it is more electronegative. It tends to withdraw more electron toward itself. So that means it will just increase the acidic strength. Likewise, if suppose I have a structure like this, and to this hydrogen, in this carbon, my halogen is attached. And one more example I have, in which I have like this, and chlorine is attached to this place. So out of this, see, there is less separation of this electronegative element from this carboxylic acid, and in this case it is slightly away from the carboxylic acid. So as the distance of electron withdrawing group increase, the acidic strength decrease, right. So that means this will be more acidic as compared to this one, because in this case the electron withdrawing group is little far from the carboxylic acid. Right. Likewise, if you have more alkyl groups, you know that alkyl groups are actually electron releasing. So we don't need electron releasing group, because if they are present, they just decrease the strength of the acid. So if these kind of alkyl groups are attached, more is the alkyl group, more is the electron releasing tendency, that means more is the plus I effect, and that means less is the strength. So as I have summed up for you, like if we talk of HCOH, in this the acidic strength is high as compared to this, as compared to this, and as compared to this, because every time you can see that here it has 1 R, it has 2 alkyl groups, it has 3 again 2 alkyl groups. So that means they are somehow decreasing the acidic strength, because as they are electron withdrawing in nature. So this is how you are going to explain, or the factors which actually affect the acidic strength. So what are the factors? One, electron withdrawing will increase the strength. Second, electronegative will increase the strength. Third, more closer the electron withdrawing group to the carboxylic acid, more will be the strength. Less is the alkyl group, more will be the acidic strength, right. So this is how you are going to explain, or if you get a question like this for reasoning, you are going to reason in this way. Likewise, the same happened with the aromatic acids. So what are aromatic acids? Which have the benzene ring, and along with that there is a carboxylic acid group which is in direct contact with the benzene ring. So here also we see that there are certain factors which increase the acidic strength, or which make the release of hydrogen ion possible. What are those factors? Again, the electron withdrawing one, because we know that electron withdrawing will somehow withdraw the electrons, and they will make the breakage of the OH bond more easy. That means the release of hydrogen ion will be more easier. So any group which show minus I effect, again the same thing, is going to increase the acidic strength. Likewise, we have seen that we can have a substituent also attached at ortho, meta and para position. So if it is attached to ortho, like if some substituent is attached at the ortho position, that means this position. So you know that it is going to behave as a strong acid. It is going, like if we have an electron withdrawing group present in the ortho position, it is going to increase the strength of an acid. Likewise, the para substituted one, that means at para position also, like if there is an electron withdrawing group, it is going to increase the acidic strength to the maximum, and if it is electron releasing group, it is going to decrease the acidic strength to the maximum. So that means para is the position where the effect is maximum, whether it is going to increase the strength, or whether it is going to decrease the strength. So it is maximum in that case. So like I have an example for you. Suppose I have an acid like this, in which I have NO2 at this position. So that means it is going to possess more strength as compared to carboxylic acid, which has chlorine at its position. It will be more than the benzoic acid. It will be more than the benzoic acid with methyl group. It will be more than the benzoic acid with OH group. So that means as the electron releasing, as the tendency to show minus I effect increase, so that means the acidic strength increase. So as we know that in this NO2 has the more effect in withdrawing the electrons. So that means it is going to possess the higher strength, and this is going to possess the hydroxide one. The one which has the hydroxide ion is going to possess the less effect, or we can say that it has the less strength. So you can get a question like this. Suppose I have this kind of thing, right, nitro group attached at the para position, and again my carboxylic acid. So if I want to, like if I ask you that whether the para nitrobenzoic acid is more powerful or more acidic strength as compared to ortho or meta, or these ones have the greater strength. So you are going to answer in this way. As we know that nitro group is electron withdrawing group, right? So that means it shows minus I effect, and at para position it shows minus R effect. So that means in both the cases it is just withdrawing the electrons, it is just decreasing the electron density. So as we know that any group which decrease the electron density is just going to increase the acidic strength. So that means it is going to, the para one is going to have the more acidic strength as compared to the ortho and the meta substituted one. Likewise, I have one more example in which I have OH group. So if I talk about the strength, then we know that it particularly show minus I effect, but at para position it show plus R effect. So that means due to minus I effect, what it does actually, it decrease the electron density as it is electron withdrawing. But plus R means it is going to increase the electron density, particularly at ortho and para position. So due to minus I it is decreasing the electron density, and due to plus R it is increasing the electron density, particularly at ortho and para position. So that means, like, if we compare the magnitude of minus I and plus R effect, we see that magnitude of plus R is much higher. So that means it is going to increase the electron density at ortho and para position, and due to which the ortho and para substituted ones, these kind of carboxylic acid, are going to be weak. They will have the strength will be weak as compared to the meta substituted. So this is how you are going to answer. Just look at that, what kind of effect they show, minus I, because particularly they should show minus I effect if they want to increase the acidic strength, right. And some groups at para positions show minus R, and some groups at certain positions show plus R. So you need to be well versed that what kind of effect actually they show at what position. Then only you will be able to answer it. The most condition which is required to increase the acidic strength is the electron withdrawing group. So more electron withdrawing is the nature, more is going to be the acidic strength. So as you all know about the acidic strength, now we are going to look for the few reactions based on this, in which what we will see that hydrogen ion will be particularly released, right. So the first reaction, what I am going to do it for you is, as we know that we can suggest the nature of acidic base by reacting it with the litmus. So what happened when we react carboxylic acid with litmus, it particularly turned blue litmus red. So it shows that it is acidic in nature. Second reaction we have is reaction with metal. Particularly I will take sodium. Suppose I have an acid, I am going to react with sodium. Sodium being more reactive is going to displace H, and as a result it is going to form sodium salt of carboxylic acid, and along with that we will get a hydrogen gas. Suppose we will take an example, let us say CH3COH acetic acid with Na, it will form sodium acetate with H2. Likewise we can react with the base also, metal hydroxide. So in this case also, when we will react with metal oxide, the same thing is going to happen. It will get cleaved from this side, it will replace this, and H and OH is going to form the water. Same we will get a sodium salt of carboxylic acid. Along with that, the byproduct changes from H2 to H2O. Likewise, we can do it with reaction with the bicarbonate or carbonate. Let us take metal carbonate and metal bicarbonate. The same reaction happens. So we have carboxylic acid, Na2CO3. So again Na is going to displace H, and we are going to get sodium salt of carboxylic acid. Along with that we will get a product CO2 and H2O. Likewise we can take NaHCO3 also, the product is going to be same. So that means all these reactions just indicate that we can just cleave this hydrogen ion, and as you have seen, this hydrogen ion is every time cleaved when we react with metal or metal hydroxide or metal carbonate or metal bicarbonate. So this just you can say that these reactions are just indicating that it has an acidic strength or it is an acid, because in it the hydrogen ion is being displaced, right. So as you all know that what is the reason behind the acidic strength now. So you are able to answer these questions related to the cleavage of OH bond. So we are done with the first reaction. So if somebody is going to ask you about the reactions directly, you are going to do the same thing as in all the reactions what you have seen, that metal is just replacing the H. And why this OH bond gets cleaved, you know now acidic strength, it is just based on the delocalization of electron, that is the resonance. So any substance which increase the decrease the electron density is going to make an acid a strong acid, or vice versa. That means any electron releasing group is just tend to destabilize the carboxylate ion, and the release of hydrogen ion will be difficult. So this is what is the first property. Now we'll start with the second property, that is the reaction due to cleavage of CO and OH bond.